Welcome to the webinar, The Benefits of X-ray Inspection Before Packaging. Before we begin, let's outline the agenda for today's webinar. We'll start by discussing the role of X-ray inspection systems in the food industry. Next, we'll explore how these systems improve food safety and quality. We'll then delve into the limits for foreign body detection and the process of conducting a hazard analysis. Following that, we'll cover the selection of control points and make a case for early inspection. Finally, we'll wrap up with a conclusion that ties everything together. In the food manufacturing industry, the detection of foreign bodies in products, just before packaging, can lead to significant production disruptions and product waste. With numerous opportunities for contaminants to enter the processing stream, from the initial reception of ingredients to the final packaging stage, ensuring food safety is a critical concern. While many manufacturers opt to install X-ray inspection systems at the end of the production line, these machines can also be placed at critical points earlier in the production process to enhance operational efficiency and food safety. Manufacturers facing challenges like labor shortages, tight margins, and regulatory pressures can benefit from strategically placed X-ray systems, and this webinar explores their vital role in X-ray inspection before packaging, highlighting the importance of implementing food safety measures well before the final stages of production. Keep watching to learn how to make informed decisions for optimal placement and the key questions that need to be answered, like, what are the benefits of installing X-ray systems at raw material arrival points? What are the common and overlooked areas for X-ray system deployment? And how does early X-ray inspection improve end product quality? Now let's discuss the role of X-ray inspection systems. X-ray inspection systems provide significant advantages over traditional inspection methods, such as metal detectors or manual inspection. X-ray can detect a wide range of foreign bodies, including stone, metal, glass, bone, and high-density plastic and rubber. These systems enhance product safety and quality by identifying and removing various contaminants, thereby protecting manufacturers from costly downtime and potential recalls. Powerful X-ray inspection systems can also perform simultaneous inline quality checks. These include measuring mass, counting components, identifying missing or broken products, monitoring fill levels, and checking for damaged products or packaging. Additionally, in meat processing plants, X-ray systems provide highly accurate chemical lean and fat content analysis for 100% throughput of meat. Incorporating X-ray inspection into your line demonstrates compliance with national and global regulations and standards. Identifying control points, CPs, and critical control points, CCPs, is essential for HACCP programs. Additionally, X-ray machines also comply with strict retailer guidelines. Let's move on to how an X-ray system improves food safety and quality. When a product passes through an X-ray machine, a grayscale image of the product is created. The software within the X-ray system analyzes the grayscale image and compares it to a predetermined acceptance standard. Based on the comparison, it accepts or rejects the image based on food safety and quality standards. In the case of a rejection, the software sends a signal to an automatic reject system, which removes the product from the production line. Recent advancements in inspection technologies, such as dual energy systems, have significantly improved the level of detail in X-ray images. Dual energy X-ray machines can identify tiny contaminants in complex images with varied densities, like those in poultry, seafood, red meat, and bulk raw materials. Now let's explore what the limits are of foreign body detection. The effectiveness of X-ray inspection in detecting foreign bodies depends on several factors, including product density and thickness. Product density determines the depth of gray in the grayscale X-ray image. The denser the product, the darker the gray. For a foreign body to be detectable, it must be denser than the product in which it is embedded. This means it will absorb more X-rays than the surrounding product and appear as a darker area on the grayscale image. Conversely, foreign bodies with a density similar to or less than the product are not detectable by X-ray inspection. As product thickness increases in the path of the X-ray beam, the overall level of absorption also increases, making detection more challenging. Foreign bodies in shallow layers of product, like those on a bulk flow production line, such as cereals or frozen berries, are easier to detect than those hidden inside a finished, sealed pack. Generally, the smaller the product thickness, the better the sensitivity of the X-ray inspection. Many other factors can affect the sensitivity of an X-ray system. So, it's important to remember that sensitivity is not uniform at every stage of a production line. Some locations are better suited for detecting certain foreign bodies than others. Next comes conducting a hazard analysis. HACCP, known as a Hazard Analysis Critical Control Point, is an international food industry standard that helps manufacturers identify, evaluate, and control significant food safety hazards. It aims to prevent contaminants from entering the production process and to catch them before products leave the factory. According to HACCP's first principle, manufacturers should perform a hazard analysis for each product to assess the risk of foreign bodies. Food or pharmaceutical safety hazards are anything that could threaten human health. Since X-ray inspection detects only physical foreign bodies, this webinar focuses on physical threats, like fragments of stone, glass, metal, bone, or high-density plastic or rubber. To conduct a hazard analysis, start by creating a flow diagram of the production process, including every operation and input, such as ingredients and packaging materials, that affects the line. For each process and input, identify potential hazards, considering both the sources and the actual hazards. Determine whether your manufacturing processes introduce, control, or increase these hazards. Next, evaluate the likelihood of each hazard occurring. Focus on relevant risks, with a reasonable chance of happening, by filtering out unlikely events. Finally, implement preventative measures to stop or reduce the risk of foreign bodies entering the product. Concentrate on operational procedures like maintenance frequency, safety inspections, visual checks, line encasing, and training. Remember, some hazards may require multiple preventative measures. A hazard analysis must identify and assess all reasonably expected hazards, including those related to the process and facilities used. It should also pinpoint potential sources of foreign bodies. For example, in the production of a snack or cereal bar, potential risks include stone and glass from incoming raw materials, sieve wire from damaged sieves, blades or paddles from mixing and blending ingredients, metal fragments from the rolling process, cutting blades from the final cutting of the bars. These examples illustrate how different foreign bodies can contaminate products at various stages of production. Let's begin discussing how to select critical control points. Even with stringent HACCP controls, risks remain. Despite rigorous measures, some foreign bodies may slip through, and new processes can introduce new contaminants. Additionally, raw ingredients from suppliers might already be contaminated upon arrival. A control point is any step where a physical hazard can be introduced and controlled. Adding additional end-to-end control measures, such as X-ray inspection, is crucial for enhancing product quality, safety, and compliance with HACCP, known as Hazard Analysis and Risk-Based Preventive Controls. The earlier a foreign body is identified and eliminated from the production line, the better. Unchecked, a single foreign body can lead to a multimillion-dollar production shutdown. Control points are generally related to product quality or regulatory compliance. By integrating control points with HACCP, food processors can establish critical control limits and procedures to detect and manage potential hazards. Raw ingredients often carry foreign bodies, so manufacturers rely on their suppliers' quality control. Some even require suppliers to use X-ray inspection to reduce contamination risks. Early detection of contaminants, like stones or metal, is crucial to prevent equipment damage and lower costs by removing them before adding value to the product. One real-world example is a cereal manufacturer that inspects all incoming ingredients using a bulk flow X-ray system to eliminate the risk of contaminated ingredients. The early detection saves the manufacturer money, as the contaminated product is rejected from the line before being processed and packaged, which minimizes product waste. In another example, a red meat processor wants incoming meat to hit a target chemical lean value. Overly fat or lean trim is a problem, as it complicates recipe construction. X-ray inspection with DEXA technology, known as dual energy X-ray absorptiometry, can inspect all incoming raw meat to eliminate contaminants, verify weight, and calculate chemical lean. The processor can verify purchased meat was accurately priced, and has the potential to increase fat claim revenue or receive other concessions from non-compliant suppliers. Bulk flow applications include raw ingredients like grains, fruits, peanuts, snacks, vegetables, meats, and seafood. These products are conveyed in a layer, typically 25 millimeters or less. This small depth offers outstanding levels of sensitivity for X-ray inspection, up to 4 times more than inspecting finished packs. Placing an X-ray system early in the process can inspect incoming goods, remove foreign bodies at the source, and trace them back to the supplier. An example of selecting control points for bulk flow product is a seafood processor, who finds it easier to remove contaminants, such as unwanted bone, hooks, and shells, early in the production process, cutting down on rework labor and minimizing packaging waste. This is done directly on the belt of a hygienically constructed machine, before the product is packaged. Regarding potato inspection, whole potatoes vary in size, and a single layer on the conveyor belt provides the best inspection capabilities for hollow heart detection. Bulk inspection early in the production process prevents machine damage further down the line by finding golf balls, rocks, stones, and needles. Pumped products like sauces, jams, ground meat, chocolate, and dairy spreads are inspected early in the process using X-ray pipeline systems. These systems, placed upstream, offer high detection levels due to the homogeneous nature of the products and the shallow inspection depth, 50 millimeters or less. This makes it easier to detect foreign bodies compared to finished products like glass jars. An example of selecting control points for pumped products is the inspection of whole poultry muscle. When raw poultry enters the line, it is deposited in bulk form into a combo dump. Then it is lifted into the tumbler, which feeds into the pump stuffer, to initiate movement through the pipe. A pipeline X-ray machine is used to inspect whole muscle product, to find 0.6 mm stainless steel, and bone down to 1 mm using enhanced dual energy. Processing changes the nature of the product, making foreign bodies harder to detect. Cooking can produce chemical changes that alter the density of physical foreign bodies. In poultry especially, cooking reduces bone density by breaking down collagen. Mechanical processing breaks foreign bodies into fragments, making detection more difficult and potentially causing damage to equipment. This can lead to costly repairs and additional metallic contaminants. Typical X-ray systems used before or during food processing are bulk flow and pipeline X-ray systems, but there is also a range of conveyorized X-ray systems available to inspect food products. Now let's build a case for early inspection. The most common location for an X-ray inspection system is after packaging and sealing, as the sealing process can introduce foreign bodies. For example, screwing lids onto glass jars can cause glass shards to fall into the product. However, X-ray inspection is more effective at detecting foreign bodies before packaging. And rejecting packaged products is costlier than rejecting products still in process. While there are benefits to post-packaging X-ray inspection, there are also several benefits to adding X-ray machines earlier in the production process, such as recover and reintegrate products before adding more value, monitor supplier quality control, prevent damage to downstream processing equipment, which saves time and money, minimize costs associated with product and packaging waste, save on rework labor, and avoid costly recalls. Before we go, let's take a few moments to summarize. Early detection of foreign bodies in the production process is more effective due to smaller product depth and uniform texture. As production progresses, contaminants can change, and each step may introduce new foreign bodies or break existing ones into smaller pieces. Because foreign bodies can be introduced at any stage, early detection reduces costs, waste, and prevents equipment damage. Food safety is crucial, and manufacturers must have reliable systems to detect contaminants. X-ray inspection systems are effective solutions, deployable at various production stages. During this webinar, we've explained the importance of early deployment of X-ray systems, as they identify and eliminate contaminants before final packaging, as well as reduce recalls, waste, and health hazards. Early installation also improves operational efficiencies, which is essential amid labor shortages, tight margins, and regulatory pressures. Thank you, and if you'd like to stay up to date with the latest product inspection trends, just follow us on social media. Connect with us on LinkedIn, follow us on Twitter at EagleXray, follow us on Facebook, and subscribe to our YouTube channel. If you wish to learn more about advanced X-ray inspection solutions, please visit www.eaglepi.com, or if you have a question, email us directly at eaglesales@eaglepi.com.